Hi guys, welcome back. Let's continue with our question. Today we are answering question from work, energy, and power. As you know, we are answering from past papers. Please get your exam pad. Try first. For each question, as you know, we are getting 30 seconds. Question 1, 5.1, let's say 5.1, right? Conservation of mechanical energy. Your 30 seconds start from now. All right, please try first. If you try, I hope you will get good mark. All right, time is going. Please write it down, your answer. Conservation of mechanical energy in words. That's 5 seconds. After that, we are going to show correct answer. If you need extra time, please stop video and then you can try. But for this one, now we are showing answer. Answer is the total mechanical energy or sum of gravitational potential energy and kinetic energy, because the mechanical energy we know, in an isolated system remains constant. Total mechanical energy in an isolated system remains constant. This is conservation of mechanical energy. We have done our first question. Let's continue with 5.2. Now, we can just explain our diagram, what is given. We have block of mass 2 kg, drop from point X. Drop means V initial equals 0. And then it's coming to position Y, point Y. There's no friction, there's no air friction. Use conservation of mechanical energy to calculate the speed of the block when it reaches point Y. All right, so you are going to calculate velocity at speed or velocity at point Y. Good luck. Your 30 seconds start now. From X to Y. Object is moving, initial is 0. Initial velocity is 0. Just remember that. Conservation of mechanical energy formula we should remember. Yes, last 2 seconds. Yes, time is over. So it is time to show correct answer. But please try first. Get your answer first. And then you can check. Now, conservation of mechanical energy, total mechanical energy at point A, point X, we should say, sorry, we should change that. In memorandum, it was given like that. But let's say X, total mechanical energy X equals total mechanical energy Y. And then, or you can write potential, what's that? Kinetic plus potential at point X, kinetic plus potential at point Y. This is our conservation mechanical energy. This one or this one, you can write, you're getting 1 mark, any of this. And then, what I know, V initial equals 0. And V final, I'm looking for that. And what else I know? Delta YH. Let's say delta, just change initial height. H1 we can write, or HX. We can say HX is equal to 5 meters. HY equals, let's write like this, HY equals 0. So initially you have only potential, kinetic energy is 0. You just check here, half m times 0 square, so it is 0. And then m times g times h. You have only potential at first position. Second position, you have only kinetic energy. So you are writing your formula, kinetic plus potential, kinetic plus potential. This one is 0, as you see it is 0. And this side, potential is 0. You are just using these two equations and then getting V done. All right, so conservation of mechanical energy, we have done question 5.2. Let's continue with next one. Next one is another question asking you work energy theorem in words. Good luck. Please try. Work energy theorem in words. Work energy theorem, remember that. Please write it down. All right. So writing and trying, very important. Please do your best. Work energy theorem. 5 seconds now. All right, time is up. So let's show work energy theorem. Work energy theorem is the net work done on an object is equal to the change in object's kinetic energy, or the work done, as you see, net, there's the remove net, work done on an object by a net force. Now just writing net force. So just adding net force here is equal to the change in object's kinetic energy. So this is our definition for work energy theorem. Most of questions coming with this definition. Now they're asking you another question. Use the work energy theorem to calculate speed of clock when it reaches point Z. So you have object. Now you have different motion. Other one, it was from point X to Y, straight dropping off. But now inclined system using, so from X to Z, now it is moving. We are looking for velocity at point Z, speed at point Z. Let's start. Okay, so 30 minutes, 30 seconds, not 30 minutes, 30 seconds, please try. Please remember, work energy theorem we are using. You have 10 seconds, and yeah. Okay, please try, please try. So quick, 30 seconds over already. But if you need extra time for this question, maybe you need extra time, you can stop video and then you can carry on. Work energy theorem equals del work net equals delta K. So work net equals delta K. So what is our work net? How many forces we have? What forces we have on this system? Friction. There is no friction. They said frictionless, so there is no friction. We have only gravitational force acting. As you know, just down we have gravitational force is going down, but we are going to use this one on surface FG parallel. All right, FG parallel. We have only that force we have. So this one perpendicular we are not using. We have FG perpendicular component of gravitational force, but we are not using that. We are using only FG parallel because on surface this one is this side we are using motion, and direction of motion this way. So what was our formula? Work net formula. Work net equals force times delta X FG parallel. This is our force now. FG parallel times delta X. Delta X is this one. So this surface distance from X to Z times cos 0. Why it is 0? Because direction of motion and direction of gravitational force, parallel gravitational force, same. If they are opposite, it's gonna be 180. But now cos 0. So work net equals m times g times sine 30. Step 1. This is my gravitational force, FG parallel, all right, times FG parallel I wrote, mg sine 30 already wrote here, times delta x, times 1, so we don't need to write, cos 0 already, 1 we know, plus 1. So mg sine 30 delta x. But as you see, they wrote mg sine 30x, yes, we understand that, this is FG parallel. But what about this? 5 over sine 30, what's going on? So what is 5 over sine 30? This is our delta x, guys. This is our delta x. From, okay, we can just clear this side. Oh, this is fine, we can use it. So this is delta x. What we know in maths paper 2, you know, sine 30 equals, next one is what? 5 over delta x. So delta x times sine 30 equals 5. And sine 30 divided by sine 30 each. You don't need to make too long, but just to understand, we are doing this way. So delta x equals, you just swap this too, it's fine. Delta x equals 5 over sine 30. As you see, I'm using delta x here. So work net equals delta ek. So from now, let's try to explain delta ek. Delta ek is equal to ek final minus EK initial. EK final formula is half 1 over 2 times m times v square minus 1 over 2 times m times v square. This is v final. This is v initial. I know v initial is 0. So this is 0. As you see, it is 0. And this side half 2, mass of object is 2. So v square. So you are writing delta EK here. And then you can calculate, you can get velocity at point Z. I hope it is clear. Work energy theorem. It is taking our time. Let's continue. Next question now. It is last one from question 5. I think it is last question for today. So they are asking you, how should the answer question 5.2 and 5.4 compared according to physics prime equal or unequal? So what they said, 5.2 and 5.4. Just let's check. All right. Now they're asking you, you are getting answer for 5.2 and 5.4, same answer. Just double check. Just quickly, let's double check. 5.4, as you see, 9,990. Start from X to Z, going down 5 meters, but using incline system. And then 5.2, what was the 5.2? Let's double check. From X to Y, straight, going down, not using incline system anymore, just going down. But why final velocity getting 9.90, same final velocity? How can we get same answer? They're asking you that question now. Explain with energy principle. So that's, 5.5, asking you why 5.2 and 5.4 equal. That's our question. Please write it down, your answer. You are going to write equal or unequal first, and then explain. That's our question. Question 5.2 and 5.0. If you use different physical principles, just different one, just getting equal. Okay, let's explain question more. I think this one is not clear. So, okay, so question 5.2, work done by conservative force does not depend on path taken. Gravitational force is only force doing work on block. It is a conservative force. Gravitational force, we are only gravitational force acting. Because of that, we are just getting same answer. And then work done by conservative force. Conservative force, gravitational force, Fg. As you know, on this system, also only gravitational force acting. And work done by gravitational force, is equal to m times g times h. Delta h, we can say change in height. So we are using this one, and then we can say equal. Even if you use conservation of mechanical energy or other energy principle, you are going to get equal answer, same answer. We checked already 5.2, 5.4, they're equal. Velocity, also work done, also will be equal. Nothing will be different because only one force acting, gravitational force acting, both of them. Only inclined system, we are using parallel component of gravitational force, but still same answer we are getting. All right, we have done for today. Thank you very much. See you next lesson. We have so we'll carry on with Doppler effect next period. Next day, another day. See you another day, guys.